Okay, hello everyone. So I've got a title that is both a mouthful and an eyeful, so I shortened it to a lightning title, Fossil Shark Gills. And so this is really a talk about the early evolution of jawed vertebrates. But why? So jawed vertebrates are a really diverse clade that includes the cartilaginous fishes, sharks, rays and elephant fishes, and the bony fishes. That's you, cows, all the other fish you can think of, lungfishes, etc. And these guys are defined by a series of exciting transformations, like paired fins, teeth, bone, all these innovations that are super cool, and we want to know more about how they evolved. The problem being that the outgroup doesn't have these things. That's the jawless fishes, lampreys and hagfishes, which makes it quite hard to study for using living taxa. So these guys have paired fins, they don't. So what? Paired fins evolved. You don't know how. So instead, we're forced to study the fossil record. And in particular, I'm going to be talking about the very earliest members of the cartilaginous fishes today. And particularly, we're going to be talking about gills. So everyone knows what a gill is. This is a basking shark showing off a splendid set. Gills are supported by these series of bony struts. So they're diagrammatically here, and there they are in the shark's mouth. And so I want you to particularly concentrate on this red bit, which is the only thing I'm going to really talk about, which are these things that lie along the bottom of the gill basket, called branchials and a basohyal at the front. And so there's a pattern of these that clearly defines cartilaginous fishes and bony fishes. In cartilaginous fishes, the very front one of these tends to only meet the first gill arch, or the hyoid arch, and it meets this light purple element, which obviously isn't light purple in life, directly. Bony fishes have this additional thing called a hyperhyal in the middle, you can see, and this big red thing tends to meet several different arches, the hyoid arch and some other gill arches. So if we want to find out, how the gill skeleton evolved, how can we try and work out which of these is the ancestral state, which was present in their ancestral jawed vertebrate? Cyclostomes aren't very much help. They do have sort of a gill basket, but it's not really comparable to their jawed vertebrate one. So we have to look at the fossils, in particular, early fossil chondrichthyans, or cartilaginous fishes. So people have done this. This is a pretty obvious thing to do. There's a super cool Nature letter a few years ago about this shark, and they argued, you can see it's got hyperhyals at the front, although weirdly it's not got this red thing, the basohyal. And they argued that the bony fish condition was the primitive state, and this shark thing where you don't have hyperhyals is derived. But its taxonomy is a bit dubious. It might well actually be a holocephalin rather than a stem shark. And so we looked at another guy, PTOMACANTHUS, and this guy's an acanthodian, which is this group of very, very early cartilaginous fishes. So here is the fish, and this is basically it's like a concretion that's the top and bottom of the head, and we're looking at the bottom. So we've got the teeth at the front, impression of the brain case here, and pharynx at the back. So hopefully, fingers crossed, we've got some gills in here. Have we? Yes, otherwise this would be a short talk. So we CT scanned it and pulled the gill skeleton out, and you can see this is that red central thing, and it's meeting the first and the second arch here. So what does this look like if we plug it into the phylogeny to try and work out how it compares to other things? Well, so there it is. Here's my dodgy interpretive drawing of it. The red thing is meeting the first and the second arch, and there's no hyperhyal. You don't see that thing you see in baby fishes. So we plot this guy into our matrix, and it has a gill skeleton that actually matches the chondrichthyan condition. And it suggests that perhaps the ancestral state isn't this osteichthyan thing after all. And this is actually confirmed by some other chondrichthyans. There's some other acanthodians that are preserved badly that seem to some interpretations show this. And there's a weird mixture of things in the crown cartilaginous fishes, which also suggests that maybe this Azarchus thing with these hyperhyals is derived. And also, importantly, stem gnathostomes, the placoderms, so these are guys that are branched off before the bonian and cartilaginous fishes, also seem to have this setup, which adds further support to the fact that this is the ancestral condition for ground gnathostomes. So that's the end. That was a mystery solved with gills. There's my acknowledgements, and if anyone has any questions, fire away.